So with that, could I invite the second panel to join me on stage? And there they are. Charles Cook, Sustainable Energy Lead from TTP, please, if I could have you join me on stage. William Harder, Project Lead from Vattenfall. Daniel Frail, the Chief Policy Officer from Hydrogen Europe, and Dimitrios Moudouris, the Chief Executive Officer from Seawinds Ocean Technology. Welcome, one and all. Very good to have you with us today. I'm going to sit forward in this chair because I'm sort of sloping down like I'm in a lazy boy there. Yeah. So this is utterly, it's a fascinating time. For all that's happened in the last 10 years in the energy transition, the game is being raised. Hydrogen is that Swiss Army knife, as is often described, of the energy transition. It's going to be, as a commodity, obviously allow for trading. It's allow for decarbonization. It's really fundamentally, if you can produce green energy, you can produce hydrogen, and you're on equal footing pretty much with anyone else in the world. So actually, the geopolitical, globally speaking, the geopolitical changes that are potentially here are tremendous. But we're going to focus on Europe because obviously, well, we are in Europe, but more to the point, Europe has led discussion in the energy transition globally in many ways, and indeed has been leading the discussion in green hydrogen to this point. Let's start with the developer's view. William Harder from Vattenfall. Vattenfall, you all know, obviously integrated energy utility and indeed a pace setter in the European wind and solar build. But also, let's not forget, has really been setting out the terms and conditions for the industrial decarbonization with hydrogen. Indeed, they are involved in a very innovative scheme, several. One is called Hybrid, you may know, which is a green steel initiative with mining companies, LKAB and steel from SAB. But we won't get into those details quite yet. Let's think about Vattenfall has a portfolio which, obviously you know better than I, but let's just run it down. At last count, 2.7 gigawatts under construction, 3.6 gigawatts in mature stage development on top of a total installed capacity of 4.2 gigs across 5 countries. So you have the power, both literally and metaphorically. Let's get your views to start with then, really on the role of utility here. What role do you see utilities such as Vattenfall having in not only a more rapid build out of wind power in Europe, but indeed to advancing green hydrogen as into a new reality?
Yeah, first of all, thank you for having me. And indeed, we've got quite a lot of capacity built out already, but we would really like to build a lot more. And we see that for a large part will be enabled by green hydrogen and by industry as well. So we have got quite a couple of industry partnerships already. And I think that one of the really interesting aspects is that in the last couple of years, we've really seen these discussions transition from what do you want us to do? Do you want to change our processes? To, okay, we are going to do this. We want more green hydrogen and we would like it a little bit sooner. So we've now actually seen a bit of a switch in us pushing our industrial partners and potential industrial partners to our industrial partners pushing us. So that is really quite an interesting experience to have, but we believe that this will really enable the whole build out as well. There are some parts, of course, we spoke about permitting, but the national grids are also quite relevant. And we see that these capacities, bottlenecks that we have in our transmission systems, not only in Sweden, the Netherlands and Germany, but in the UK and other countries as well, that these are problems that we can bypass completely if we would move to offshore hydrogen production. So there you would enable this transition of industry. You would enable a more rapid build out of large-scale hydrogen production at the same time. And it's quite nice to see that go hand in hand, because these really are partnerships. So as Vattenfall, we are quite open for these. And you mentioned one already, Hybrid, the first fossil-free steel has been produced. I got a little piece at home. We now have a Volvo truck that has been produced with fossil-free steel in operation. And a while ago, we published some partnerships that we have with Preem and ST1 on sustainable aviation fuel production and e-fuel production. That is really going towards the gigawatt scales.
Very good. Well, thank you for that. I think, again, many elements we can dig into a bit. But Daniel Frill, maybe I could sort of turn to you. For those who don't know, of course, before Daniel was with Hydrogen Europe, he was with Wind Europe. So he actually has a very sort of windy view of a lot of the way Europe functions in its energy transition. But could you sort of expand the circle slightly? Here's a developer's view, but obviously there are many developers, and indeed we see developers actually sort of coming into the game that previously weren't, sort of players, as it were. Could you start by just outlining the challenge as you see it here? Again, constructing the gigawatts of wind and solar plant, indeed building the factories required by these sectors to manufacture the turbines, the panels, as well as the electrolyzers, and we'll come on to that. Again, this is a monumental task. permitting was mentioned. I mean, what do you see as the key levers to be pulled here to really, to really do what Vattenfall is doing, but on an industry-wide scale?
Yeah, thanks. Thanks for the invitation as well. So permitting definitely it's an issue. And even if politicians want to accelerate the build-up of renewables, it has an inertia. So even if you increase targets, at least for the wind sector onshore, for the next 3 years, there isn't much more that you can actually do. Yeah? If you look into wind onshore park, which go through an auction system and has to connect to the grid. But so there is a large pipeline as well of those projects that are waiting, right?
Yes.
Now, if you have the possibility to already build your project, not having to connect to the grid, directly connect to an electrolyzer, that gives you a lot of advantage. Yeah? So that's also important. So we can reduce this, let's say, inertia or this delay that anyway you will gonna have. And obviously it's shorter for PV. You can build a big PV park in a few weeks, yeah?
Yes.
In a few months for an electrolyzer. So I think we are able to ramp up if we are able to be independent from the grid. Because otherwise, like in the case of offshore, takes you 10 years. These 10 years are not because of the permitting. These 10 years are because you have to wait for the grid to be there.
Yes.
And the grid is not there.
Yes.
So I think that we will be able to solve if we are able to go off-grid. Yeah?
Okay.
The other challenge is to ramp up the electrolyzer capacity. We are talking about having, in order to produce around 10 million tons of hydrogen, we will need in the order of 130 gigawatts of electrolyzers in Europe. Yeah? Today, we don't even have half gigawatt installed.
Right. So.
The companies are willing to make the big step to change to the gigawatt scale production. Mm-hmm. But the reality is that they don't have the orders. They have all MAUs, they have a lot of agreements, a lot of ambition, but they don't have orders coming in. Until those orders don't come in, they are not going to make the big investments, yeah? And that will take us also a few years. So I think a big challenge is on the electrolyzer, and I think the previous speaker mentioned the lack of skill, the lack of people, so that's going to be also quite challenging. Now, what we might see is that we're creating a market for hydrogen, renewable hydrogen. We are not allowing the electrolyzer manufacturing in Europe to ramp up too quickly. In the meantime, Chinese and other places are doing that.
Yes.
And if we don't take care of creating the value chain in Europe, we're going to see the same that happened with PV 10 years ago. So those will ramp up quickly, they will get support from the government, and they will be selling their products in Europe very soon, sooner than we think. So we need to be careful of that.
Yeah, well, again, nothing happens in a vacuum, of course, and indeed, every market is global very quickly, especially when obviously the revenues that lie in wait, as it were, are there to be had. This is what you mentioned, obviously, many fascinating points there, Daniel. I wanted to turn to Charles Cook here because I think let's talk. Okay, the core technology is the electrolyzer. That's established. But TTP is taking a rather different tack on this in many ways. I mean, that is to say, you're looking at the manufacturability of electrolyzers and then sort of working back to how to best develop that technology, rather than here's our beautifully gilt-edged piece of technology, and now what do we do with it? Could you just tell us a bit about sort of about your approach, because TTP is a different sort of animal when it comes to the renewable energy sort of evolution, as it were.
Yeah. No, the different approach is we're taking a different technical approach, but we're also taking a different business model approach. So we're 300 engineers and scientists on a single site, and effectively we exist to accelerate the energy transition, to accelerate people's projects. So people come to us with a challenge, and we can assemble a team that's suitably qualified and make whatever they're doing happen more quickly. And in terms of how does technology, what role does it have to play in ramping up green hydrogen faster? As you mentioned, technology has a big role to play in designing things that can be made cheaper. So there's an economy of scale that you get anyway when you make things when you make more units of something.
Yes.
But to really make the most of that, the trick that we can see is to use components that already have a very large economy of scale. So if you need a pump, for example, use something that's used in the automotive industry because it's already made by the millions. If you need to make a component that doesn't exist already, design it in a way that means it can be made on a machine that's already being sold. That you can go to the Hanover Messe and buy the machine already. And in that way, we can make the cost of the unit cost of the electrolyser lower. But the other thing that I think is really important, which has been talked about, which you mentioned just now, is the sort of investment that's needed to get ready for large-scale manufacture. If we can design the systems to use existing manufacturing infrastructure, then the investment required is much lower. So we can leverage things that are already out there, that are already making other products and systems, and just pivot them towards green hydrogen and electrolysers.
This really resonates very clearly around this industrial transformation theme, doesn't it? I mean, fundamentally, as you rightly say, this is about investment on some fundamental level, and we know that new technology actually scares investors for the most part, doesn't it? I mean, the untried, the unproven. If we can use, as you say, component parts that are already well known as tried and true and tried and tested in the industry, then invariably that money should be easier to get into the system, and indeed, mass production would follow on from that. Thank you for that, Charles. So I want to sort of take a bit of a tangential turn here and come across to Dimitrios. I mean, Seawinds, a very interesting company if you haven't been following them over the years, but they have a particularly interesting project now, which they announced earlier this week, which has all the right. Makes all the right noises in many ways. I mean, it's a 3.2 gigawatt floating wind project off Sardinia. In of itself, we all get very excited about floating wind at that sort of scale. But what's particularly interesting, if I may say, is that this is going to be both electrons and molecules. So 1 gigawatt worth of that production is going to go into hydrogen. Now, there are all sorts of challenges in this project. It's in 2,800 meters of water. It is floating in and of itself. It's obviously less proven than bottom-fixed offshore wind. And when we were talking yesterday, Dimitrios said, well, he certainly did raise some eyebrows when we announced it. So let's start with that. I mean, I'm sure you like raising eyebrows, and we all need to raise more eyebrows, so long as those eyebrows then, if I can carry the metaphor, then furrow and we get down to work. So tell us a bit about the HyMed is the project's name, and why this makes economic sense, and indeed what difference it could really make to the way Europe thinks about hydrogen generation in deep water, because we know the winds are strong and it's a rich wind stream, and we can get hydrogen electrolyzers need this. They want the base load power. So how does this project work, and why should we believe in it?
Thank you. First of all, thank you for inviting me into the panel today. I'm sure, as you said, the announcement raised a few eyebrows. I would say I'd like to explain what we are as a let's say company first. We have 3 business lines. Our first business line is to create wind turbines. We have our own patented technology. We want to provide operation and maintenance for the units that we're going to sell to the market, but also we have a small line of business which we create concessions. Concessions to specific and targeted countries where the permitting system is defined to a certain extent, and we can calculate the risk, let's say, on the permitting. We can afford, let's say, an investment to start the permitting for a project, and we found that in Italy. HyMed is a project with a big ambition. Big scale project, 3.2 gigawatt. We have a COD in 2030, but we do believe that the project is going to first produce electricity, supplying the electricity into the grid, there's a well-defined process in Italy on how this is going to work out in terms of permitting, in terms of pricing, sale of the price of electricity into the grid. But we also do know that the grids have imbalances. The grids do not need the same electricity that they need during the night. And we are focusing on that, on how to exploit that. How would we exploit the wind that is during the night quite abundant in the location that we have chosen? How are we going to make sure that this electricity is not lost? And there comes the element of hydrogen. But the hydrogen is not cost effective if you take the electricity from the grid. It has to be, the electricity has to come before the electricity goes into the grid, so you can produce the hydrogen in a cost-effective way.
And a green way, for that matter.
In a green way, obviously, yes. And Europe is on a mandate, let's say, to go and make hydrogen their main fuel. If we don't have a cost-effective strategy on how to reach that big-scale production of hydrogen, then we're putting this mandate at risk. So first, we need to be sure that we, to activate the hydrogen, the green hydrogen transition, we have to electrify the green hydrogen transition with cost-effective electricity. Cost-effective electricity comes where actually the winds are consistent throughout the day, throughout the year, and this is in the Mediterranean Sea, this is in ultra-deep waters. Ultra-deep waters might ring a lot of bells and might raise more eyebrows than the size of the project, but we believe that there are companies there that we are talking, that this is going to be fully de-risked. This aspect of ultra-deep waters and the floating wind in ultra-deep waters is going to be quite fast de-risked in the minds of developers, in the minds of international energy companies. Our partnership with Aquaterra is based on that fact. We want to start the permitting. We've already started the permitting actually for the HYMED, and we are discussing grid connection points with the national grid. We're also having the first scoping reports issued for the HYMED also, but we need technical expertise to understand the cost ratio between electrons and molecules. And this is part of what Aquaterra is going to be doing with us. So we're going to provide a solid technical folder to the authorities in Italy so they can promote or they can progress the permitting of such a project. Again, I have to stress that is a project that is going to be first producing electricity into the grid, so the project will be making money.
Yep.
And then the element of hydrogen is going to be introduced with a COD again in 2030. Okay. So I guess I've explained it as
I think obviously we always talk about scale and scalability in renewables, don't we? And here's a case where a project this scale will, I presume, convince a lot of doubters. I mean, coming on stream. So it's hugely important at that level. Let's stay with the offshore wind. Thank you for those comments and those insights, Dimitrios. Let's stick with the offshore wind theme for a minute, and we'll come back to you, William, because what Vattenfall's doing off Scotland right now is a very different approach to this, but fundamentally has the same longer-term ambition, and that is to say to really make the the industrial marriage of offshore wind and hydrogen viable, economically saleable, and convincing to any who might doubt its power. You're installing a number of electrolysers in turbines at the European Offshore Wind Deployment Centre, which, for those who don't know, is off Aberdeen, and was actually quite high profile for a while because it spoiled the view off Donald Trump's golf course there, and he tried to delay it for many years, and of course failed in the end. But all to say, that's not why we're talking about it. What we're talking about it is that you will be running, in theory, the first turbine with electrolyser built in of its kind in the world. So maybe could you tell us a bit about the ambition there, but also the early lessons, because this is what the wider industry needs to know. It's one thing for you to do it, but how we can all benefit from that knowledge is also very important.
Yeah, so the Hydrogen Turbine 1 project is the second step in our fourth step to gigawatt scale, where the first one is in Norway with Technip FMC, and then the second indeed in Aberdeen. And here we're going out to shore, offshore, and we're actually building it. And this enables us to run into the problems that we will at some point. And one of those typically has to do with permitting once again. But in this case, it's not about having long times to actually get your permit, but currently there is no government authority that is willing to receive your permit application. There is nobody that says, yes, fossil-free hydrogen pipelines are within our mandate. So we kind of expected these kind of challenges, being a trailblazing project, and of course there is no legislation for things that are never done. But it's really quite interesting. However, we're quite happy with the UK government on this aspect. We received funding from the UK Department for Business, Energy and Industrial Strategy, £9.3 million. And this also helps us, of course, financially quite significantly. We're very grateful for that aspect. But it's also made sure that government on different levels, all levels, is aware of these challenges. And they also see that this is not a Vattenfall problem, this is an industry challenge that we need to overcome.
Yep.
So that is really something that we would invite the governments of Europe to look at. Do the one side, of course, the whole permitting thing in general, I think that's well discussed, but also, do we actually cover all parts that we are going to need for offshore hydrogen production? And the reason why we think that this offshore part is such an important key in getting high volume, low cost green hydrogen, all the good stuff, is that your offshore electrical export infrastructure really is quite expensive. Your offshore substation, they're amazing pieces of work, they're also absolutely enormous and quite capex heavy.
Yep.
So if you can replace that with a pipeline infrastructure, and we believe we can, then on a 1.5 gigawatt wind farm, depending a bit on how far out to sea you are, what depth you're in, we see that you could save about 500 million euros just in capex reduction. And that it does not include the electrolyser installation just yet, but assuming that you need the hydrogen in the end, and this is really an underlying assumption for us. If you produce hydrogen, you do that because you need the hydrogen and you're using this for something that cannot be electrified. Yeah. Because that is how we believe that the hydrogen is used best. We've got the steel industry, sustainable aviation fuels, mentioned that a little bit. But that is really what we're getting towards. So once we then have this in Aberdeen, we're moving towards a commercial project planned for 2026. Hopefully be able to make an announcement on that one within a couple of months.
Yeah, very good.
And then the 2029 number is then for the multiple gigawatt scale over the West Coast.
That's right, so very stepping stone approach. And of course, it should be said too, the hydrogen produced by these turbines will be piped to shore, to the port of Aberdeen. So here we have, and there's method of madness here, here we have the hydrogen reaching shore and now having decarbonization potential for any industry on
exactly.
shore. So, and with on that note, maybe I could come back to you, Daniel Frail. We've heard in the first panel, we've been discussing here, this is, hydrogen takes energy transition into industrial transformation because of the decarbonization potential. Hydrogen Europe produced a report a few months ago which found or calculated that the average primary steel plant in the EU would require 1.2 to 1.3 gigawatts of renewable powered hydrogen electrolyzers running at full load to produce enough green hydrogen to extract iron from iron ore. So here we are. I mean, steel obviously is one of the steel production is one of the biggest emitters on the planet. Can you say a bit more about that study, about that report, and really what the implications are? Because this could be enormous, right?
Yeah, sure. But before I answer that question, I want to react to one thing that happened just
a live debate. How about that? Hey, here we go.
Maybe people don't see or go unnoticed, but there was the feeling that when he was saying, well, it's better to produce hydrogen off-grid, not connected to the grid, and you say, yeah, pure green or real green, that's green. As if hydrogen produced with grid electricity is not green. And I think we need to be, or electricity taken from the grid is not green. And I think we need to be careful not being more religious than the Pope here. If you look, RE100, we know this initiative, all the corporates wants to go clean or green, None of them have ever talked about that they have to be off-grid, connected directly to a renewable power asset to become renewables.
Yes.
You can be connected, you can have a PPA, they even accept GOs, okay? Can agree that this is probably greenwashing, but PPAs with a grid-connected renewable energy asset is green, and it's renewable, and it's good. So let's not start saying that renewable hydrogen, if it's coming from the grid, is not green.
No, but it's the potential there, of course. There's other things around the grid too.
Yeah, I didn't want to. Of course, there is an issue about the competitiveness of it. And if you're going to go into the grid, you're going to have to pay network charges. You're out of business. It's not competitive. So you rather go for off-grid solutions if you can. But this is a different discussion on whether it's green or not. Now, I come to the steel, which is another point I want to touch upon. If you, as you say, 1.2, 1.3 gigawatts of electrolyzer for a typical steel plant, Now, one of the findings of the study, because we were looking really at what the conditions of renewable hydrogen definition were at the time, this was before summer, is that you need to do an hourly matching of your hydrogen production and your renewable energy assets. What we found out that if you want to do that, if you want to implement that, you will need to put battery storage. But the battery storage will be in the hundreds or thousands of gigawatt hours of capacity to allow you to run your electrolyzer almost at full load, which means this is impossible. The largest storage systems, battery storage, we're talking about 2-3 gigawatt hours. So it's out of question. You cannot do that. Yeah. So we consider that if you will go to temporal correlation monthly, then we are talking about you can do that without storage. You can produce around 50% of your hydrogen, renewable hydrogen, yeah? And that will at least meet the targets in the industry. If you need to put the storage and you need to complement to make sure that you comply with the existing draft legislation, we're talking about increasing the investment to the double of what it would be otherwise. So I think we need to be very careful of not, as I say, not putting too much pressure on the definition of renewable hydrogen, because none of the projects will be viable. And if they are not viable, you need to pop them up with a lot of subsidy, but there will be not enough money. So we need to be a little bit cautious about that and not killing the baby before it's born, yeah?
Yeah. No, entirely true, of course, true. Well, thank you for all those points. Were you leaning to make a comment? It seemed you were keen to say something there, but maybe I misread your facial expression, did I? Or?
Okay.
So let's come back to you, Charles Cook. Again, one thing I find fascinating in all these discussions is, again, this industrial transformation theme that we're approaching things differently fundamentally. If you look at the oil and gas industry, and I was a reporter in oil and gas for 14 years before we launched Recharge many years ago now. It was such a vertically orientated well, not just supply chain, but you had an operator on the top, and everyone else hung on for dear life, and costs were pressed down, and all the pain was suffered further and further down the supply chain. But we were already hearing any discussion we've had so far is talking about partnerships, collaboration, new models of cooperation, and so. All that in preamble to say what TTP has signed a deal recently with a Canadian technology company, and I'm going to mispronounce this, but Yanmar, is it?
Yeah, Ionamar.
Yanmar, okay, not too bad. It looks on page harder to pronounce than it in fact is. And they design next generation ion exchange membranes and polymers. Now that sounds obviously deeply techy, but what's really interesting here is obviously what you're doing in developing a most manufacturable or mass manufacturable electrolyzer needs this particular technology to really, to improve efficiency, to lower costs, and so on. So can you say a bit about, again, how you're developing the technology in tandem with Ionmar, but also, again, how you're approaching the collaboration itself, because, this is, again, how you sort of punch above your weight in many ways.
Okay, yeah, we're tackling two big challenges that we heard in the first panel. One is cost and the need for some sort of subsidy, and if we can bring the cost of green hydrogen down by making it use fewer kilowatt hours per kilogram of hydrogen, so make it more efficient. That'll reduce the operating costs, and if we can reduce the purchase cost, the capex cost of the electrolyzers themselves, then we'll bring the commercial case for green hydrogen much more in parity with competitors and reduce the need for subsidies and market distortion, and it just means that there's a level playing field. So it's all about getting costs down, and we generally work for client companies developing stuff, but in this case we were impatient to get started on this project because we could see some real potential of working with Ionamar, because their AEM technology fundamentally means that you can avoid using iridium and platinum. Right. So that means brings the cost of the system, the potential cost of the system down. So there are other things you need to do to make the system low cost as well. And we've got our own particular IP in that. And as you introduced before, that's all to do with how we make the components, where we source things from, how we make it so it can be put together rapidly and without large investment. So so what we're aiming to do, we're a technology company that's been around for sort of 30 years. So we've got the benefits of being like a startup. We're a project-based organization. People at TTP, if they've got an idea, they can pull together experts from all sorts of different fields to get something done. So we've got the scale, but we've also got the startup agility, and we're not prepared to wait for anything, which is why we just got started on our own and found the Ionamar sort of link that enabled us to build on the massive progress they've made and turn it into actual a system that can be deployed.
And this, of course, this partnership model will carry on to the developer level as well, right? When you come to build your gigafactories and so on, presumably.
Yes, that's right. We've got partnerships sort of downstream as well with end users. We've got a memorandum of understanding with Plus Zero, who are producing green hydrogen on the Western Isles. And yeah, ultimately our vision is to have the kind of to have a project that external people can come into. It's all about partnership with us and leveraging the strengths of other people to make things happen faster. Other people can come in, adopt our projects, build a business around it, set up a gigafactory, produce stacks in the same way that sort of Panasonic and LG are making cells. And then we can supply those to a global network of people who put together systems that are customized for particular applications. So sort of mega systems that go in deserts to use PV power for exporting ammonia, down to small systems that sit on shore next to the wind power being generated with the hydrogen coming in. So yeah, systems of all different scales, but served by this sort of ultra low cost stack.
Very good, thank you for that. And if I could just sort of pick up that thread and come back to you, Dimitrios. I mean, that's not just the manufacturability, but that is developing a better electrolyzer. I mean, this is a kind of pure technology discussion. How do you make a number of better mousetrap, but a better electrolyzer. But I wanted to come back to you, Dimitrios, because floating wind in some ways is in a similar situation as conceptually. That is to say, we have to build better floating wind, more efficient floating wind to make it economically viable. And in many ways, hydrogen could be the handmaiden here, right? If you talk to DNV, they say, look, get 120 miles offshore, take that power trunk line out of the equation. That's a huge economic savings. Start thinking about floating wind as this, this pure power play, pure power source for hydrogen production. Then you open up so many different options around green shipping, deep sea aquaculture, and so on. But I mean, could you just touch on the floating wind technology? I know you're technology agnostic, even though you have your own in-house design, if you like. But really, how you're looking at that cost rationale when it comes to producing hydrogen for the future applications it will have.
Okay, with regards to the HYMED, we put our developer hat on.
Yeah.
So we have to be technology agnostic. We need to increase the competitiveness. Everybody, the speakers before me, talked about competitiveness. So how do you increase that? You provide the platform for new technologies, for technologies that have not been mainstream, to be able to come and bid or come and provide their solution. We ourselves, we have a defined program of de-risking our technology. We will not impose it into the project. We will look at the project with the glasses of somebody that is a developer and wants to provide the best solution for the project, technical on hydrogen or floating wind, in order for the project to make money. This is the key point here. Projects that do not make money, they get killed. So this is not our view. We will compete though, as a new technology, after we de-risk our technology. We will compete head-to-head with, let's say, providers of floating solutions and providers of wind turbine solutions. So we will increase the competitiveness in that industry, which is key. Floating wind in Italy, we've been very targeted and very selective to start from Italy. It is fast-track becoming non-greenfield. We have silently sold electricity projects, smaller in scale, in the past month, and we will be selling another 2 projects in the next coming weeks and months of pure electricity. So the permitting system is there. The permitting system and the response from the Italian authorities is there. So for us to be able to leverage on this and put it on a bigger scale, it makes sense. Starting with floating wind. So the projects that we sold are all floating wind. So there are off-takers of electricity in the industry. There are off-takers of hydrogen, again, from the industry. And there are international energy companies that are willing to have portfolio, starting with floating wind in Italy, which is classed as a greenfield. There is the permitting system there. We have to, of course, accelerate that. We have to simplify that. But we also have to increase competitiveness. So we will never impede, let's say, a project from our side that we are promoting and we're developing just to satisfy sales of wind turbines. Yep. But we will compete. Yep. Head to head.
Very good, yes, and I think the gauntlet is down. William, you wanted to say something?
Yes, indeed. So on the matter of reducing risk, I really believe that this is quite relevant because we have a bit of a chicken and egg problem, but I believe it's solvable as usual with some government support. And it is, we as a hydrogen project developer, energy developer, vertically integrated, we would like to have turbines on the market that are made to produce hydrogen, that have a deep integration between the generator and the electrolyser, thereby reducing capex, reducing electrical losses, producing simply more hydrogen per square meter of blade, so to say. And on the other side, we have the suppliers that could do this, but they're looking at us, say, yeah, okay, sure, we could do that, but where is your FID? Because then we know that we can actually sell these products. Well, you may say, these suppliers should be a little braver, have a little bit more trust in their own products, but these are significant investments, and I do understand. How you could change it is to have dedicated tenders for offshore, maybe onshore as well, that are for hydrogen production. So for a government, this would make a lot of sense, because in many, many countries, the government, the country, would carry the cost for the build-out of that transmission grid that is required. So that you would reduce. As a country, you get a lot of hydrogen coming in, and I think we're all very aware that this is more urgent than it has been. And it gives that confidence to these turbine suppliers that whoever wins it, they're going to have a customer. And it also gives a bit of confidence for us as a utility that we will actually have sites where we can do this, where the permitting process is not in the way. And that may actually solve that problem without costing a government money at all. It will save them money instead.
Thank you for that. I mean, Daniel, do you want to pick up on that point? Because it seems to me again this question of how do we encourage? What do European governments need to do better to speed the combined advance of renewables plant and hydrogen production when it comes to permitting, for instance?
I fully agree with what I just said.
Yeah.
I think you need a clear support scheme, which is announced long in advance. You have a lot of certainty for the manufacturers to also be able to develop the technology for the infrastructure, whichever it is, if it's a pipeline, submarine pipeline for pure hydrogen, to be also available. And I think Francois mentioned it before. I mean, we don't have those support schemes in most cases because we're still waiting for a definition of renewable hydrogen. So I think it's about time that we close that chapter and we start working on the specific support instruments.
Again, I guess it has that kind of collaborative resonance again, doesn't it? I mean, to really understand what the industry needs and to provide that partial support, as we I think as William put it. So very good. Let's come back to you, if I might, Charles. So I mean, beyond the discussion of wind and solar sector supply chains that we need to manufacture the generators as they are of green power, Europe does need to establish a supply chain of hydrogen and again reduce bottlenecks and make best use of available manufacturing capacity. When we were talking before this briefing, you mentioned that for one, the question you put was should stacks be mass produced like EV cells, and this again sort of extrapolates out to this kind of industrial transformation discussion, and then sold to integrators for assembly and so on. I mean, can you just outline some of the central considerations you feel need to be in the mix here when it comes to hydrogen technology in terms of ramping up electrolyzer deployment in the coming years?
Yeah, I think at the moment there are a lot of if you look at the market for electrolyzer systems, there are a lot of systems that are 1 megawatt or 5 megawatt, and if you buy a certain number of those, they're like kind of building blocks until you've got the capacity that you want. But I think as things move forward and we want to scale up, there's a problem there for operators in the sense that they're kind of single source, that if you want to if you have a problem with your electrolyzer, you have to go have to go back to the person who sold it to you, and that produces a sort of single sourcing risk, and it's a barrier to investment, I think. And a solution to this would be to kind of produce standard, or to establish standard interfaces between different parts of the electrolyzer supply chain. So, for example, stacks could be one element that has a standard interface to all the balance of plant around it, and that would enable those components to be made really efficiently in very high numbers, and then they could be bought and integrated into solutions for particular sites by third parties who might have a different set of skills. So rather than operating gigafactories making the same thing over and over again at the very optimized cost, they would be producing custom systems. And to go back to the point that you made earlier about tighter integration. So, for example, if you've got a wind turbine that's driving an electrolyzer, then there are some things you can do on the electrolyzer side and the wind turbine side to save costs that make those things plug in more directly together. So if the integrator of that system could select standard components that are cost optimized, have been made in gigafactories, and put them together particular for that application, you'd end up with a better solution, and also a more sort of bankable solution and future-proof solution, because if one of those components then fails 10 years down the track, then the operator has the option to go to a number of different suppliers who will make a replacement with the same interfaces.
Okay, very good. Thank you for that, Charles. Maybe it sounds a bit counterintuitive. I did want to bring in Daniel, battery and other energy storage technologies. Again, until hydrogen had this kind of, was kind of catapulted forward as the kind of, well, not quite the savior of the energy transition, but certainly the supercharger of the energy transition. We were forever talking about, how you could, obviously, lithium-ion batteries were more modularizable, and they could be, we start using these in mass numbers. We obviously, some of the long duration energy storage technologies were being discussed as so serving that role. But in the context of hydrogen's place in this ecosystem, industrial ecosystem, fundamentally, the more hours of electrolyzer operation there are per day, the cheaper the levelized cost of hydrogen. But obviously, so energy storage would be required to keep these things going. So all of a sudden, even energy storage of a non-hydrogen sort has a role, sort of new role to play. I mean, so how do you see that really taking shape? Especially when we're going to start building, obviously EVs in great number, and then the batteries will all be sort of soaked up in some ways by that supply chain.
The first time I got a proposal for a project, so 3 years ago or so, where they showed me that to deliver renewable hydrogen, they need to invest massively in storage batteries. I was very surprised. Like, what the hell are they doing, these guys? They don't know what they're doing, yeah? Why would you? I mean, hydrogen is the future storage carrier vehicle for renewable energy. So why would you actually need additional storage to produce hydrogen? It makes no sense. Yeah. Of course, this was meant, and it's still today designed in order to meet this hourly matching. Yeah. For me, it makes economic no sense. It's a bit of a bullshit, yeah? Now, you might still want to put batteries, yeah? If you want to optimize your design of your plant, yeah? Then you can put a little bit. I think that's probably good. You can increase a bit your capacity factor, but it has to be small. The batteries are extremely expensive. And need to think system-wide, because we're going to go into a huge scale of investment. So have you ever thought that if we develop PV or wind, we need to put a battery in every single plant? It's absurd. You have some batteries in some system to provide frequency services. We're talking about very, very high capacity, but very short storage. And this is good to integrate into the grid. But you will never think of putting massive batteries next to a wind farm so that you have more reliable power supply, unless you are in a big grid constraint. Yep. So it's a very specific solution for very specific cases. And I think we should at least think system-wide as well for hydrogen. You will produce hydrogen, and if you need a bit more storage, maybe you can use some storage from the grid, a little bit on-site maybe, but not using batteries to increase your full load hours from 40 to 80.
Yeah,
That's crazy.
That's right.
And one point you mentioned as well, that we will have a lot of EVs, a lot of batteries available from EVs. I think that's what you said at the end. And I think we need to be more cautious, because I've seen this vehicle to grid services already defined like 6-7 years ago, and we still haven't seen commercial operations of that. And probably because it's very hard to access the battery of someone else, and this access to this battery will obviously lead to degradation and things like that. And so how do you share those costs between the one who gets the service and the one who owns the battery? It's still very complex. So I will not count a lot on those batteries from those vehicles.
No, so I suppose fits finally into that all the above discussion, doesn't it? Once upon a time we were much more sectoral, much more siloed. We thought that wind could do one thing, solar another, batteries, and now hydrogen a fourth. But fundamentally, this is about the an intelligent integration of the right technologies for greatest efficiency. Well, I'm sort of conscious that time is actually more than marching on. We're actually winding down. So I wanted to offer sort of we go across sort of last thoughts really, without being too. I mean, we can all say we're optimistic, and I think that's probably a useful starting point. But what does optimism mean to you, Dimitrios, when it comes to renewable energy and hydrogen, and how this accelerates our chances, improves our chances, accelerates our transition away from fossil fuels?
We believe in ambition, competitiveness, and also calculated, bold moves. This reflects of our partnership with Aquaterra. We are discussing with like-minded companies, and we are moving forward with the transition. To be able to do this transition effectively, on the production side, we believe that there needs to be also parallel investments in the infrastructure. So the hydrogen will require quite a lot of pipeline network to be distributed, possibly also subsea pipelines to be transferred and transport to shore. There is these investments that needs to start getting into the frame in parallel with the production side.
Yep.
We took the first step. We took the first punch, let's say, of going into a bigger scale and planning for big scale projects, floating wind big scale projects in ultra deep waters. But this is still, again, there's the ability to de-risk all this. We take examples from oil and gas. They have been operating in ultra deep waters many years, decades. So we see that this transfer of knowledge will happen.
Okay, very good, thank you. William, your final thoughts.
No, there's a nice bridge there. You mentioned the oil and gas business, and there we really see two industries coming together, because to properly deal with hydrogen offshore, we're going to need experience from people that have been working in the oil and gas business for a long time. So we very much welcome and are open to people with that experience to help us out for those aspects. There's a lot of integration that needs to be done, and a lot of cultures that need to match together, both sort of social but also technical. Okay. And in addition to that, for the HG1 project, shameless plug, we still have some hydrogen available for sale, so welcome to reach out. But I think we're really quite optimistic. We see this pickup of industrial actors that are now pushing us instead of us them. It's super inspiring.
Okay, very good. Daniel, you've seen it from at least two sides of the table. How are you feeling?
I want to build on this collaboration between the gas and the electricity sector. I think it's super important, and as I think we should stop creating this polarization debate and this discussion between electricity wall and indirect electrification or molecules, and because it's just delaying. It's just making some people believe, electric vehicle, that's the sole solution. And we heard this morning, of course that's not going to be the case. And hydrogen is for this, and this, and nothing more. I mean, how can we even give ourselves the privilege to even determine what this technology is for and so on? I mean, I think we need to be a little bit more open-minded, yeah, and allow this collaboration to accelerate, because we have no time.
Very good, thank you. Last word to you, Charles.
Okay, I think there's a lot of reason to be very optimistic. I think if you look at the sort of portfolio of technologies that we have across different industries, if we take the right elements and put them together in a clever way, I think there's a little bit of work to do to put a lot of previous work to sort of stand on the shoulders of giants, so to speak, in the words of you two and someone else before that. If we can do a little bit of work to knit those things together, then we can get the full sort of industrial might of Europe to work together to ramp this thing up really quickly. But I think we need to work in partnership, and we need to leverage everything that's out there and talk to each other.
Very good. One for all for one. Excellent. Okay, well, please join me in thanking our panelists today. I thought of a really lively and you know, for me, quite revelatory discussion at many levels. So thank you all very much.
Thank you.
Okay, and thank you all for attending. I hope you all sign up to our Hydrogen Insight. It'll go live on the 5th of October, as I said earlier. Great things ahead. Thank you all. Thanks.